Good afternoon, everyone. I think we are under a bit of a time constraint, so I'll try to make this as quick as possible. So I'm Robin, and we'll be going through a bit about self-hosted IoT. And so I'm actually representing both the community partners here, IoTify and Simly. And what I'm about to show right now has nothing to do with either. So this is just basically going to be some of the things that I use on a day-to-day basis. So it's a lot of this is improv. To be very honest, I was troubleshooting a few issues with the demo to such an extent that I did not prepare a very comprehensive set of slides. So we're going to run through this really quick and then move on to some demos. And I think the audience today have been really great, really interactive. So I'm really counting on that to pull through this. So feel free to interrupt me, ask questions. Don't wait for a Q&A session or something. Feel free to talk. So as for me, I am a hobbyist and a tinkerer. And by tinkerer, I mean I like to take things apart. I like to basically add my own spin to things. And the easiest way to find me is my website. It's very outdated, but you can find my social links there. Now, this is one term that I think most of you can relate to here, hackers. Now, hackers have taken this, the word hacker has taken this connotation of a cybersecurity threat. But if you say, take the clock 10 years to the past, hackers were people who liked to take things apart, liked to make mods. So if there was a PC that was sold by IBM, or if there was a certain refrigerator company, or basically well-integrated things, taking them apart, making slight mods, these people were called hackers. And you can see how the tangent would go towards the cybersecurity definition of hackers that we know today. So what I like to, the reason I bring this up is this talk is for hackers. This talk is for people who sort of like getting their hands dirty with bits, you can say, not soil. Essentially, in those cases, if you don't mind troubleshooting a bit, I would not suggest, I would not have this HomeAssistant IoT installation in my parents' home. This is what I have in my flat in Bangalore. Whatever goes wrong, I am responsible and I debug it. I do not have people yelling at me. So if you try the stuff that I show, I encourage you to try. But if you have other people sharing your living space and you introduce this to them and things break, do not blame me. Nonetheless, I encourage it. Now, in the next aspect that we are going to focus on. So how many of you have at least one smart bulb or a smart switch or okay, probably not Alexa, but any other IoT device? Okay, there's a significant number. I'm pretty sure if you go to, how many of you got from Amazon? Do you see the product here? Sonos, yeah, so Homemate is an Indian version of that. Wipro is one, Cisco, either of these three relatable. These are all white labeled versions of one company called Tuya, right? So that's actually one major advantage that we'll see here. And so what essentially happens is, even though these are sold by the same company called Tuya, or these are made by the same company, this is what is called a white label solution. So Wipro goes to Tuya and says, I want to release a smart bulb, or Cisco goes to Tuya and says, I want to release a smart bulb, a 9-watt smart bulb into the market, and Tuya says, okay, here's your customized app, and then they have an entirely customized app with their branding and stuff. But if you open the app side by side, I think, I have that here, it's going to be more or less the same, right? So what I've stumbled upon is connect everything to Tuya's app. Tuya has their own app called Smart Life. Connect everything to that, and then eventually you get API access to that. It's still using Tuya servers, but still you can use Tuya APIs to control these apps. So this is basically purchased hardware. The one that you see on the left is the Wipro Smart Light. In between there's a smart switch which you can have inline to a AC circuit, and then the right one is a plug which you have in between your appliance and the actual wall outlet. Now, the app that I mentioned. This is the DIY alternative. This is just something that I think that the board on the left, that's a Node MCU based board that has been running for 6 years now. So that was actually made as part of my undergrad second year or first year when I was trying to get into a student team. Still going well. It's actually running the RGB lights to one of my servers, which also I'll introduce to. The one on the right is an ESP32 module with a camera. So that's a very easy way to DIY a security camera. Quite simple and straightforward there. We'll go through that as well. So this is where I'd like to bring this HomeAssistant project. I'm not affiliated with them in any way. This is just something that I have been using for about a year now. And the idea is, instead of having, like I mentioned, connecting all of these appliances to the Tuya app is one way. But what happens when you have DIY devices or other integrations and automations that you want? HomeAssistant is a very good solution there because it's open source, it's community driven, it has a very large user base. Anyone following Linus Tech Tips here? Okay, so he has this powering his new home and its automations and things like that. So it supports the latest, I think somebody had asked me about Matter and Thread support. So this has extensions for Matter, Thread. You can have a Z-Wave dongle plugged into a HomeAssistant server. And most importantly, this was actually built to be run on a Raspberry Pi. Except Raspberry Pis are really expensive now for one. And I like the luxury of having a bit of additional compute power. Don't we all? So, and also local control. So one of my friends sitting here, if there are cases where internet goes out, you absolutely lose all control you have over your Internet of Things device. And this is the biggest argument that I have to make to my family when I talk about automating stuff and connecting them to the internet. What happens when the internet goes down? So this actually gives you a way of controlling your devices locally. Now this is the server that I mentioned. I call it Appledore. It's a Sherlock's reference. You actually see a lot of Sherlock breadcrumbs scattered through here. Any Sherlock fans? Okay, not a lot. Okay, I see a couple. Nice. The movie or the TV series? There's only one right answer. Okay, never mind. And of course, we've seen quite a few demos not succeed today. So quick prior to the demo gods before I switch to showing you guys a few live examples. So quick tour of the home lab itself. So Appledore that you saw. Actually, it also hosts a VPN. So most of your enterprise companies, they would require you to log into your company server, right? So what you actually see right now is not my laptop's desktop. Essentially, you can see it's RDPing into a desktop that I have in my own infrastructure. So this is Appledore. It has 12 threads, 32 cores, and here you can see HomeAssistant running as a virtual machine. So if you have a Raspberry Pi, the process is more or less the same. You flash it into an SD card, boot it up, you connect a keyboard and a mouse, and you'll get a more or less the same installation. Here, this thing is actually called, this is a VNC console that you get to your HomeAssistant instance, and that actually makes it easier to interact with your HomeAssistant virtual machine. So there are also, I should probably mention, there are two ways of running this. One is within Docker, and we love Docker here. This is of course the Docker community, but HomeAssistant within Docker has a few restrictions. I think Docker in Docker was brought up in a conversation context here that happened here earlier. So there are a few limitations in terms of performance and throughput when you run Docker in Docker. And for those reasons, they actually insist that you run HomeAssistant as an operating system natively. So that's why HAOS is this project. So that's why they recommend that you flash it on a SD card or run it as a virtual machine like I have going here. Giving you an overview into HomeAssistant itself, let's see. So you can basically create dashboards like this here. Mine's not well organized yet, but you can see some of the devices that I have over here. One is this. This is actually a key light that I have as part of the video call setup. That is going to be one of the appliances we are going to be controlling. The stream is a bit slow, but anyways, so you can see all of the devices are essentially mapped to Home Assistant entities. So in Home Assistant, you have devices and then you have entities. Yeah, the light turned on. Wow. Right. The FPS in the dashboard is quite low. It happens faster. But either ways, so the idea here is you go to Tuya. So for example, the Wipro or the Cisco app that you have is quite similar to the Tuya app. Then you sign up to this Tuya IoT debugging platform. Where is the device list? So these are some of the devices that I have: key lights, backlights, water heater, bedroom lights, office lights, so on and so forth. So you get a device ID, and then this is what I mentioned initially. You can control it via the Tuya API. This is just a REST API explorer. I hope everyone's familiar with REST APIs. Anybody who's not? REST APIs? HTTP APIs. Okay, cool. So this actually gives you an interface to connect. So, but then this still goes through Tuya. So you send a request through the internet to Tuya server that connects to this. So you basically try to get the device credentials. So how this works is Tuya has certain device encryption keys and secrets that are required to make a connection or send a command to this device, and we need to fetch that somehow. So that is essentially where you try to use these debugger tools from the device itself. I'm not going to show it right now because this is being recorded and I don't want my bedroom lights flashing with somebody taking my secret key. Once you get the functionality though, you can port it. Sorry? It's not being recorded? Okay. I don't want to risk it nonetheless. The truth is I forgot where to find it. Either way. So now you have this extension called local Tuya. Again, the miracle of open source. If there's a problem, somebody has tried to fix it already. If not, it's on you to try. So local Tuya, you can see 5 devices and entities here. Let me just walk you through trying to configure something. In most cases, it will auto-discover. If not, you can try to submit something here. So you have your protocol version. So local Tuya is sort of like it's essentially Tuya APIs, but you take those secrets and then you send them locally itself. So there's a concept called MDNS, multicast DNS. So in that way, the device tries to make itself known in the local network that, hey, this is the IP address through which you can reach me. So it tries to auto-discover. MQTT. But this protocol version that you see here, this might not be MQTT number 3, this is Tuya's API spec. But the device themselves actually communicate through MQTT. They are actually ESP8266 devices within the bulbs. So there are people who go one step further. Right now I'm still using local Tuya with Tuya's firmware, but if you really want to go a step further, there are people who open up the bulbs and then connect a serial programmer and change the firmware on that as well. I don't want to go to the extent of opening up my tube light, so I am stopping here for now. Maybe in the next talk, I'll come with a tube light that's half open. So here you give your local key. This is what you would get from the Tuya device app. And then you have to essentially map, can I just get by with some random keys? Yeah, that's not going to communicate through. Either way, so then you actually map the functionality to the device themselves. Now this is not very stable. It needs a bit of tinkering to get it to work. But once you get it to work, the advantage is that you can essentially get an API kind of approach here. So for example, how many of you are familiar with Postman? Okay, I hope the others are familiar with curl or HTTP or some way to send an HTTP request. So this is a post. Sorry? Oh, yeah. Plug of your own startup. Nice. I'll entertain it. I'll allow it, I mean. So here I'm going to toggle a particular light that I had pointed at that camera. And here, this is the entity name and the entity ID. And once I send this post request, you will get a response with that it has turned off. Earlier we had toggled it on, right? So let me, yeah, so that has turned off. Let's just send the post request again. And that should have turned on any second now. Yeah, just to make sure the stream was running. So the video that you see here is actually being streamed by an ESP32. So we'll come to that in a second. For now, I had limited amount of cameras, so I'm using the ESP32 as one of the cameras. Moving forward to the ESP8266 and ESP32. So this is where a project called ESP Home comes in. So I think a lot of people here would have used ESP8266 or ESP32 as part of Arduino IDE, right? You would have flashed some firmware. I did that for the longest time, and I am an ECE graduate, but there are cases where I don't want to hard code credentials and handle versioning. I like the luxuries of OTA updates. We had an extended group discussion on over-the-air updates. So that's where ESP Home comes in. So what ESP Home is a way, due to the limitations of time, I'm not going into the details of what it is. It actually enables you to write your entire requirement as a YAML, and then have that create a binary which you can flash onto your chip over the air. So if I want to make any configuration changes, I will just go to this device. So ESP Cam is what was sending that stream that you saw a bit earlier. The code should be online. So here, if you check the YAML configuration, so here there are entities within this as well. So ESP camera, so I'm configuring the various parameters of the camera. And once you upload this firmware, then it will appear as a device on HomeAssistant. And that's the stream that you saw earlier. This is a, I think, 800 by 600 resolution image. So an ESP32 cam module is around 700 rupees. And you can get better resolution out of this. I just started working on this about, the camera itself about 1 week ago. There's a lot of fine tuning. 1 weekend ago is 1 weekend ago, because I have a full-time job to handle as well. So there's a lot of fine tuning. You can get a better resolution out of this. People have done gesture recognition out of this. You can connect this to a video recorder, and you can by all means use this as an IP camera. And there are a lot of people who have done really cool stuff with an ESP32. And another module that I have going here is a Node MCU, which is the other board, the one that has been running for 6 years. So here, this is actually connected to RGB, to an RGB light strip. So it's Darlington transistors driving a RGB light strip. So here, I literally have my webcam pointed at. This is Appledore, the server that I mentioned earlier. Right now, light's red. I can go to my dashboard and server lights, and change it to some other color, maybe. Yeah, that's changed. Let's try green, and that's green. So yeah, so what the key takeaways from here are essentially. Also, one other advantage is I'll try to basically add all of this to a VLAN and then try to cut off internet as well. And all of this remote access that you're seeing here is done through something called Tailscale. It's something called an overlay network, some SDN concepts, software defined networking concepts here, a bit too out of scope for this. But Tailscale, Tailscale. So in that way you can have your file servers and everything remotely accessible. The point being that if you have something exposed to the internet, that becomes a bit of a vulnerability. So it depends on the degree that you want to go into. If you trust Tuya and Wipro with all of that, by all means, that's fine. You also have to just factor in the reliability of those systems. So So with this, I can even have a button matrix, or I can have a simple remote controller to control this. There are people even using repurposed tablets or cheap tablets as dashboards. So whatever you saw here, whatever the dashboard that I was controlling with, this is actually fully customizable, controllable. You can have a tablet embedded in your wall that can make these modifications, edits, so on and so forth. And yeah, it's entirely customizable, and it's good for tinkerers basically. It's good for something that you can host on your own. You learn a lot of concepts within networking as well, as in the learning comes from troubleshooting. So it's a good exercise in terms. But it has become much more stable in the recent past, and it's much more stable when you run it as a VM or on a Raspberry Pi. So Docker is not something I recommend for HomeAssistant specifically. And I think with that, I have 2 minutes left for Q&A.
So you mentioned that Tuya company, right? So
yeah.
They support Sonoff.
Tuya, Sonoff, no, they are two different companies.
So I have to, like, the API that Tuya gives me to control the devices.
Yep.
If I want that in Sonoff, do I have to flash task mode in, or like I have no other option?
Yeah, if you have Sonoff, ESP Home or Tasmota is your best bet. Actually, I would prefer ESP Home over Tasmota because Tasmota.
I have to flash it into the thing, right?
Oh, into Sonoff.
Into Sonoff.
Yeah, if you have Sonoff, you're a bit out of luck.
Yeah. Okay.
But Sonoff might have a separate, like I showed local Tuya, there might be a local Sonoff or something, some kind of a, because Sonoff is quite popular, so that might very well be there. Yeah.
Are you ever concerned about security of these things? My impression is that IoT devices have very poor software update policy, and you are putting these things inside your home.
Yeah.
And it's potentially exposed to internet. So like.
Yeah. So the next step is that I'm going to cut off internet entirely.
But after you've optimized.
Sorry.
What?
No. In a few weeks, as in once I figure out the VLAN partitions and stuff, I'm going to try and cut it off entirely. But there is a good amount of cryptography going on here. I'm not going to say that just because it's a Chinese company, it's not secure. IT is IT, network packet routing is network packet routing. If you have a segmented VLAN with, how do I explain horizontal? Fine. So if there is a breach into your network, it can be contained if you partition your network adequately. So as far as the consumer is concerned, there's a certain degree of trust you put in your vendor, as in when you pair one of these apps with your phone, or one of these bulbs with your phone, there's a key exchange that's happening, and it's tied to your account. So long as your account is not compromised, it shouldn't be there. One good security step that I recommend is go to your router settings or whatever and disable UPnP, Universal Plug and Play. That is one popular breach that has been there, but UPnP still exists because there are a lot of games, PlayStation and stuff require that to expose certain ports to the internet. So if you have UPnP turned off, that means the only way you can expose a port out is only if you explicitly declare it. As long as you're not explicitly opening a port outside, you should be fine in most cases, unless your vendor's this is breached, your vendor's server is breached. In that case, that degree of trust you have with your vendor is what's the problem.
So the API call you made, that was over HTTP, right?
The API call that I made was?
So the postman you just showed us that.
That's local, 192.168.
But still HTTP.
Sorry? It's local. It's that port is not available from outside the internet, outside my local network. Even now, I'm VPN'd into my network. There's an encrypted tunnel that I am using to get into my local network. There's nothing exposed to the internet from that network. So trust me, I've tried to expose services to the internet for a very long time till I found Tailscale. And now I'm working on completely walling off. The problem is carrier grade NAT, as in there's a network address translation layer that sits between your ISP and your local router, which makes it very difficult for any outbound communication to come in. So it requires a great deal of effort, except for UPnP, to get a port open through this.
Cloudflare also has a similar solution that they create a.
Sorry?
Cloudflare also has a similar solution.
Zero trust. but that is for TCP traffic, and that also gives you SSL termination and HTTPS. I use it for basic file sharing. Like if I don't want any security, I just want to transfer a file which is considerably large in size to a friend. I'll just put it in my NAS and then have that shared. Cloudflare. CLOUDFLARE. Any other questions? Most routers, they'll have a checkbox about universal plug and play, and you can disable that from there. Tailscale and zero tier come under the category of overlay networks. Zero tier is a proprietary protocol, whereas Tailscale uses WireGuard underneath. WireGuard is a pretty standard enterprise VPN. Any other questions? Yes, everyone's hungry? Cool, alright then. Thank you so much, you've been a really great audience, and thanks for Docker community for the opportunity to speak as well. If you are an enterprise or if you are working on IoT or backend testing, I encourage you to check out IoTify, and that's the company that I work for. So we are into IoT testing, and Simuli is a IoT learning tool. So it actually allows you to use a virtual Raspberry Pi.
Okay, thanks. Thanks, Robin. Thanks for your talk. Okay, so we have a next speaker, Abhishek.